Hello ladies and gentlemen, and welcome to my presentation on the Lille Langebro Bridge in Copenhagen. My name's Simon Fryer and I work for Bureau Happold. This is the format of my presentation. I'm going to cover all aspects through from the concept design through to the final installation of the bridge, with special mention made to an innovative new central moment connection. So let's start with the concept design. This is the bridge site. You can see right here, it's very central in Copenhagen. And this is an existing bridge over the harbour called the Langebro. Our brief was to design a new pedestrian and cycle bridge alongside the Langebro, which is not a particularly comfortable route for those users. You can see here some of the design criteria that were set as part of the competition brief, which was launched in 2014. Key things are that we had to provide quite a large navigation channel. It's still quite a busy harbour, 35 meters clear width, and also the bridge is relatively wide for a foot and cycle bridge. It's 7 meters wide to accommodate two-way cyclists and a dedicated footway. So looking at the site, and this is the existing Langebro, as I mentioned, which is a road bridge, bascule bridge with an opening section. Just going from A to B, our new bridge would have followed the alignment shown on the screen at the moment. However, we wanted to align the bridge to the axes of the approaches on either side, so we decided to introduce some curvature. And then in order to provide some clearance under the bridge even when it's in its closed state, we raised the bridge, and that also had the advantage of giving some nice viewpoints potentially of the harbour and the city. So here's the bridge alignment as we determined it. In terms of its form, the bridge was inspired partly by the movement of a bird's wings as it flaps up and down. So you can see that the main structural elements on the edges of the bridge go up and down according to the position along its length and according to the structural demand at any particular point. And here you see how that manifests itself as quite an interesting warping of these main triangular edge members, introducing doubly curved steel plates and associated fabrication and design complexity. Here's a render of the bridge in its closed state. You can see the existing Langebro alongside. There's a control tower here which is used to control the lifting of this bascule bridge, and equally is also used to control our new bridge here. And this is how the bridge opens to allow vessels through the navigation span. So there are two rotating sections of bridge, so it's a swing bridge. Okay, so let's move on now to the structural design of this quite complex bridge. Here you see the bridge in plan. You can see the navigation channel clearly marked. The bridge is divided into a number of sections, and there are 4 piers in the harbour and abutments at either end of the bridge. These 2 piers, the most central piers, incorporate the rotating mechanism which allows the bridge to swing open. This is how the bridge is articulated, and you can note that these are the movement joints which allow the bridge to these sections to rotate, and then there's this moment connection in the center, a mechanical connection, which I'll go into in a bit more detail in a moment. This is what the piers look like. They are tapering and inclined to improve the appearance. And here are some of the steel details of the deck itself. So the main members are triangular in shape. They have stiffening diaphragms inside. The outer plates are typically 15 millimeters thick, which allows them to be doubly curved. But in places they are reinforced with internal stiffeners where the stresses are otherwise would be too high. Some more details. You can see the sort of intricacy of some of these elements. There are trough sections which span between the main members on either side to stiffen the deck plate. One of the most important things to consider when designing a movable bridge is the effect of heat. We were particularly conscious of the complexity of our structure and the need to accurately predict thermal effects and how the movements would affect the joints, and make sure that we had enough tolerance in them so that the structure wouldn't jam, for example. So we undertook quite a comprehensive shading study. Using the Rhino model that we had for the structure, we could tell which plates would be heated at different times of the year and different times of the day, and we applied a multitude of different cases to the structure in order to derive an envelope of thermal movements and stresses. Okay, so one of the defining aspects of the bridge design is to try to keep it as slender as possible, quite apart from making it look as aesthetically pleasing as we could. We wanted to ensure that there were good views for the bridge users of the harbour, and we didn't want a deep structure which would destroy that. Ordinarily in this sort of structure you'd have a pinned connection at the centre. When the two moving parts come together, a pin would be driven between the two just to align the two parts, but our design incorporates a moment connection which clamps rather than pins the center of the bridge when it closes, and this effectively means that the bridge is continuous, and therefore we can keep it more slender than if it had a pin in that position. So there is a pair of cylinders on each side of the bridge, a compression element at the top and a tension element at the bottom, and that provides the moment connection. You can see some details of those elements, all made up of standard hydraulic rams and parts, but used in a new and unique way. These are the sockets. That's the compression socket which receives the compression element, and this is the tension socket. And here you see how the two elements are energized. So as the bridge closes, the sockets are designed to interlock with the parts on the cylinders. The compression pin is driven into position, and then the tension element is energized, and then the whole thing is locked from a moment point of view. And finally, once the operation has been completed, some preload is applied to the cylinders. This is a diagram just showing how it works. Actually, moment can be resisted, but you can see that actually thermal expansion and contraction doesn't result in any resistance in the cylinders, because they are connected together, and the hydraulic fluid can flow from one to the other. Okay, let's now take a look at how the bridge was fabricated. This is one of the sections in the workshop, and this is the jig on which the section was made, and here you can see how the complex geometry had to be replicated in the jig, which was quite complex in its own right. All the bridge pieces were laser cut and delivered as a kit to be welded together in the factory, and a number of the elements were doubly curved, and here you can see the specialist plate bending being undertaken, with the plates being doubly curved to quite a high degree of accuracy. The bridge was actually built upside down because that made the welding easier. Most of the welding was from underneath, and then the sections were taken outside and flipped. And here you see a bridge section having been through the paint shop, waiting on the quayside in Hollandia's yard in Rotterdam, ready to be delivered to Copenhagen. All the sections were put on a barge and transported by sea from Rotterdam to Copenhagen. And this is the large shear leg crane that was used to install the pieces on site. That's the site ready for the bridge sections to be installed. That's a view of the mechanism inside one of the piers with a slewing ring to allow the rotation. And here you see the bridge sections being lifted. And finally, the bridge was opened in August 2019. One or two pictures of the finished structure. So just to quickly summarize, I think this is a pretty unique structure, amazing project to have worked on. A central moment connection allows the bridge to be much more slender than a traditional approach would, and I didn't really have time to go into a lot of detail about the fabrication, but hopefully you can see that the quality was absolutely fantastic. Thank you very much.